Hello. So like I said, we are going to start with questions from 5.2, and we're going to do that throughout most of the beginning of in this first session before the break. And then we'll probably just get started on 5.3 right before we take the break, and then we will do more examples from 5.3 after. The good news is that there's not really anything new to learn other than ways to use the Z table differently. So hold on just a second. I'm gonna try to straighten that out a little bit so you don't have to look at me all tilted the whole time. Okay. So I already got a couple of questions from 5.2, so I'd like to address those first that I got by email. So I had two different people ask me about question 6, I think, and question 5. So, and they're really the same kind of question. So let's look at one of those. Let's look at question 6 in particular. And we can look at question 5 also, but I believe it was really the same kind of question. So we're going to go to question 6 on 5.2. So I'd like for you to open up my stat lab so that you can do your question 6 as well, because I'd like to give everybody the opportunity to get through question 6 and see if any problems come up. All right, so everybody open up my stat lab, open up your class, and go to your 5.2 homework question number 6. And I'm going to do the same, and we'll do this together. And this one has a lot of it has like 3 or 4 parts, and they are good questions for reviewing this section and for reviewing what we've done so far. So this is a really good one to go over. So the question people had was mainly over part A. So we're definitely going to look at part A and see how that is supposed to be done. Included in this is I'm going to show you the way I would want your work to look if you were showing work on a test. All right. So the way you show your work is important because it's kind of like the way you write a sentence is important. You want your work to make sense. So the first thing I'm going to do when you are showing your work, the first thing you should always do is write the given information. So I'm going to write the given information for number 6. And yours may be a little bit different than mine. So either write mine down and do mine with me, or write your given information and make sure you don't mix the two up. So on mine, it says, in a recent year, the scores for the reading portion of a test were normally distributed with a mean of 21.2. So I'm going to put mu equals 21.2. And a standard deviation of 5.4. So that means lowercase sigma is 5.4. That's the symbol for the standard deviation. And it says complete parts A through D. So I'm doing part A. I'm going to label part A. If you're doing your work, if I actually ask you to show the work for all the parts, then you should have them labeled. So part A says, find the probability. Now, I'm not going to write out all these words. We did a whole chapter on probability, so I'm going to use my probability notation. And this one says, find the probability that a randomly selected high school student who took the reading portion of the test has a score. So a score is a data value, so that's the probability that X is less than 20. So this is the question. Now, here's where it comes in. I want to make sure that you're showing your work correctly. Okay, so when you are finding the z-score, you're not doing probability. You are just finding the z-score for that data value there. So you see this number 20? So I'm going to put here, I'm going to actually write out this step that we're going to do. We're going to find the z-score for x equal 20. So I'm going to write my formula. You might not write the formula every time. You might go ahead and put the numbers in it because we've been doing z-scores for a while. But I'm going to go ahead and write the formula. Just is x minus mu divided by sigma. So the z-score for x equal to 20 is going to be 20 minus 21.2 divided by sigma, which was 5.4. If you will get in the habit of always carrying your labels down, I know it takes an extra millisecond or two, but the more you organize your work, the fewer mistakes you will make. So I'm going to do that in my calculator. I'm not going to do this in pieces. I'm just going to put it in my calculator just like this with the parentheses. And I get negative 0.222 repeating. Now that's not the number I'm going to look up. That's also not the number I'm going to change the problem to, right? So before I do anything else, the way I've been showing you, before you do anything else, is we're going to round the z-score to 2 places because we're going to use the table. Now, there is a way to look up normal probability questions in a calculator using technology, also in Excel. Excel will do normal probabilities. Okay, and when you use technology like a calculator or Excel, we don't usually round this. But if you're going to use a table like we're going to do, you need to round this to the places that the table has. In our case, our table uses 2 places, and typically z-scores are rounded to 2 places. So if I round this to 2 places, I get z equals negative 0.2. I'm going to keep that 2 because the very next number is less than 5. So this is the z-score. That's not my answer. That's the z-score for that data value. So now I'm going to change this problem. This probability that x is less than 20 now becomes a new probability statement. The new probability will be the probability that the z-score is less than, and that's what all this work was here for, is to find the z-score for x equals 20. So the probability that the data value is less than 20, that's the same question as saying, what's the probability the z-score is less than negative 0.22? It's the same question. So I've rewritten the probability statement using the z-score. Notice this work here, this is just scratch work. This is just to find out for this data set what the z-score for 20 would be. And that would be different for different data sets because the mean and the standard deviation are different for different data sets. Okay, so now I've got this question. I'm going to draw a picture of this, even though less than is right in the table, but still I want you to get in the habit of drawing a picture. So I'm going to draw a small picture for this. And of the standard normal distribution, that uses z-scores that has 0 in the middle. And I'm going to put this z-score on my picture. And I'm going to put it to the left of 0 because it's negative, and I'm going to draw a line. And if I'm looking for the probability that z is less than this number, that means I'm looking for the area under the standard normal curve to the left. Less than means to the left. That happens to be what our table gives us, is the area to the left. So when we look this up in the table, negative 0.22, and let's practice using the table. So I'm going to bring the table up, and we're going to practice again using the table to find the area to the left of negative 0.22. So I'm going to bring up the z table, and we want the negative side of the table. So here's the negative side of the table. I'm going to enlarge mine a little bit because kind of hard to see. And I'm looking up, so the first two parts under the z column, I'm looking for negative 0.2. Now the column I'm going to use is this one here because the number in the hundreds place. Remember, I'm looking up z equals negative 0.22. So that number there tells me to look in this column right here. That tells me which column to look in. But for that first part, for this part, that tells me which row to look at. So remember, I'm looking at this column. I'm just going to put a line down around this column. Looking in this column. And I'm looking for negative 0.2. That's right here. So I'm looking in this row. And remember, that's why I drew these blue lines down, so I could see I want this column and this row. And I can see that the intersection is going to be that number there, 0.4129. And that is the area to the left because the table gives you area to the left. So let me show you how I'm going to write that on my work and on my picture. So I got 0.4129. That's this area to the left. By writing it here on my picture, I'm indicating that I looked it up in a table, and that was the area to the left. On this part, since they're asking for the area to the left, and the table gave us the area to the left, then we don't really have any other work. So that means our probability, if I had room right beside that, I would write it right beside it. So I'm going to rewrite it, though, since I don't have room. So this probability, I just rewrote the question. Because if I had room over here, I'd write it over there. Equals that 0.4129. Now, and that, so about 41% probability that randomly selected test score student would be less than 20. That's what we just found out. But to answer that question, we had to find the z-score so we could use the table. Now, here was the question that people had, and it's a valid question. So I had a couple of people ask about this. There's a couple of mistakes that I'm seeing. First of all, let me talk about the mistakes, and then we'll talk about why my stat lab looks like it's giving the wrong answer. Okay. So first, places where you have to be careful. One, make sure you're using the correct side of the table. If it's negative, make sure you're looking on the negative side. If it's positive, the positive side. Two, make sure you're rounding correctly. And you're always going to round before you look it up in the table. So you want to make sure you round this to 2 places. So let's write that down. That's important here. Is in order before we use the table, we're going to round this to 2 places. Then the other thing, so those 2 things, make sure you're using the correct side of the table. Make sure that you've rounded the z-score before you look it up. And then the third thing is to make sure you're looking at the right row. Because it's easy when you see 0.2, or I've had, the one that really throws people is when the z-score is like negative 0.025 or something like that. And let's say that's what we came up with a z-score. Well, people want to look up 2.5, but that 5 is not in the hundredths place. The 2 is in the hundredths place. So what you're going to round this to would be negative 0.03. And this would be the z-score you would look up in the table, which means the column, this is one of people, this is a very common mistake, an easy mistake to make. I want to show you in the column. If you were looking up negative 0.0, if you're looking up negative 0.03, I want to show you which row you would look at. So if I'm looking up, I'm going to write that down again. If I had a z-score of negative 0.03, that means the row that I'm going to look up is negative 0.0. That 3 is the number in the hundredths place, and that's going to tell me which column to look at. But the row I'm going to look at, so I'm looking at this column here. But the row I need to look at is this one right here. So I'm looking at this row, this column, so that would be the number right there. So when there's a 0 in the tenths place, that throws people. So try to be careful when you're looking the number up in the table. Okay, one other thing. Before we go on, we'll do the B part. I'm going to give you some time to finish the A part, and we're going to go on to the B part on this one. Is that the couple of people that emailed me, after they missed it, they're looking at my StatLab to see what its correct answer is. For example, on this one, let me erase the answer. That was just me making up another thing up here, so let me erase that. The final answer we got was this, 0.4129. However, if you were to miss it, that's probably not the answer that you would see as the correct answer. Now, when I put that in, it counted it right. Okay, it did count it correct. But had I missed it, when I looked at the answer there, it probably would not, it may not say 0.4129. It may say a number that's not even on the table. It would be close to this, but not identical. That's because my StatLab has 2 acceptable answers for every question. One of the answers is using the table, and the other answer is using technology. And when they use technology, like a calculator or Excel, they don't round the z-score. They use the entire z-score, and it gives them a slightly different area to the left. So that's why, so when you see an answer there, and you say, well, I don't understand how they got that. That number's not even in the table. And the reason, anytime you see an area or probability that's not on your table, that means that they're showing you the answer you would get using technology. So don't worry about it, though, because if you do it right with the table, it will count your answer right. Okay? Just that if you do it wrong, the answer it shows you as the right answer might not be a number in the table. I know that's weird, but basically don't worry about it. Just do a similar exercise and make sure that you're very careful looking the number up in the table. So I want to give you a chance. I'm going to give you a few minutes. For those of you watching the recording, you do the same. Take a few minutes and try to do the parts of question number 6 on 5.2. I'm going to check roll while you're working on that, especially make sure you do at least part A if you haven't already done it. If you missed it, try it again, right? Being very careful, and please show your work like I've indicated. So write the given information down, the mean and the standard deviation. Write the question with the data, with the X. Find the z-score. This is actually the part of the work here. Find the z-score for that data value. Then rewrite the probability statement using z instead of x, replacing this number with its z-score. Drawing a picture. I want you to get good at drawing a picture. And let's see if you get the answer right. So everybody take a little bit of time to part A the way I want it to look. If you get done pretty fast and you get it right, then go on to part B. And we'll be doing part B together in a minute. I'm going to leave this up so that you can see it. And I'm going to check roll. They're working. So when I call your name, please raise your hand. Ariana? Cecil? Diamond? Kayla? Christina? Mia? Stephanie Garza? Okay, thank you. You can put your hands down. When you have finished question 6, part A, raise your hand again and leave it up. That way, if everybody's already done this, I'm not sitting here waiting for you to do something that's already done. Good. Yeah, just leave your hands up, and that way I'll know. I'm going to give the other 3 a chance to finish theirs. Then we'll go to part B. Go on to part B if you've do all the parts. I know you may have done all the parts. If you've done all the parts, then either work more on any questions you've missed or go to past homework while we're waiting. So those of you who have finished this, did you get the right answer? Or do you have a question? If you have a question, type it in the chat or turn on your mic and talk. I think we had a couple that hadn't finished yet. Was it, I don't remember. Mia or Christina, do either of you have questions? Did you get yours right?
Yes, sorry.
That's fine. Ariana, I can't remember if I saw your hand up that you finished. Did you get the first part of question 6 right?
Yes.
Okay, terrific. Stephanie, how about you? I don't remember if I saw your hand up.
I got done. I was one of the last ones to finish.
You got it, Diamond?
Yes.
Okay, perfect. Stephanie, did you get yours? Stephanie, are you there? I didn't. Are you working on it? Do you have it pulled up? Or are you not able to work on it right now? You do? Okay. So you didn't get the right answer. Let's take your let's take your mu standard deviation, Stephanie. What did it give you for the mean on your problem?
$22.7.
And what's the standard deviation on your problem, Stephanie?
It's 6.5.
6.5. And on your question for part A, what did it say? Find the probability that a randomly selected test score is below what number? What was the number in yours?
Less than 19.
19?
Yes.
Okay. So what we're going to do is we're going to take Stephanie's numbers here and look at the different parts for hers. Okay, so I'm using one of your examples instead of mine. Okay, so on Stephanie's, hers says this, and so when she finds the z-score, when you find the z-score, Stephanie, you should have had the x, this 19, minus the mean, divided by 6.5, which was your standard deviation. So let's first check to see that your z-score is correct. And go ahead and turn off your microphone, Stephanie, so that.
Oh, okay.
Thank you. I wish you could all leave your microphones on all the time. I would like that better. So when you write your z-score in, your z-score that you should have used, Stephanie, would have been negative 0.57. So let's check. It actually came out negative 0.569. So did you round your z-score to this? That's the first question.
Yes, it came out to that.
Okay, so that's the number we're going to put right here. Okay, so we're practicing this one more time. And then you should have drawn a picture. So I'm just going to do this real fast. Your 0, negative 0.57 is over here to the left of 0. And we shade this area. Then now the next thing we need to check is if you looked the right number up in the z table. So do you have a z table printed off, Stephanie, to use?
Yes, I have it with me.
Okay, great. So make sure, first of all, that you're on the negative side of it. And in the column, we're going to look at negative 0.5. I'm sorry, in the row, on the row under Z, we're going to look up negative 0.5, which is down towards the bottom. And then we need to look in the column that says 0.07. And I'm seeing 0.2843.
Oh, okay.
So that means the probability 0.2843. So can you figure out what you were you looking at the wrong place in the table or something?
Yeah, I think so. I was
Okay.
looking on the other one.
Okay. All right. Yeah, you have to make sure you're on the correct side or it'll give you the wrong answer. Let's go to the B part of this. So, Stephanie, let's just stick with yours since I have your numbers up here. Can you tell me what the B part said on yours? So we're moving on to the B part. And since I have your mean and standard deviation up here, Stephanie, tell me what your B part says, or you won't be able to until you put in your answer for the A part.
It says scoring between 17.9 and 27.5.
27.5?
Yes, ma'am.
Okay, so does it look like I have the right two numbers here? And notice how I wrote that when it says between.
Oh, okay, yeah. Yes.
Okay, so when you're doing a between problem, this is how you're going to write the original question, right? So on this one, we're going to have to find two z-scores. We're going to have to find a z-score for x equals 17.9, and we're going to find the z-score for that. We're going to find a z-score for x equal 27.5, so that we can rewrite this as a probability that the z-score is between two numbers. That's our goal. So we're trying this number and this number. All right?
We subtract them?
Yeah, so
Oh, okay.
but when we're done, right now we need to find these z-scores. Okay? So we're not going to subtract these numbers. With these numbers, we're going to use the mean and the standard deviation again to find the z-score. So right now we're going to look for those two numbers right there. We need those numbers before we can draw our picture, because our picture has to have z-scores on it, not data values. So for the z-score for this, we're going to have 17.9 minus the mean was 22.7, and divided by the standard deviation. I'm going to do that in my calculator, and that's going to give me, and I'm going to round to two places.
Is it negative 0.74?
Yes.
Okay.
So there's the z-score for that one. So for this one, I'm going to put in here negative 0.74. That's the number that's going to go there. Now, let's do the z-score for 27.5. So for 27.5, do you notice I'm doing the z-score? Notice this is separate work. This isn't what I'm writing in the probability. The only numbers I'm writing in the probability are the z-scores that I have found for these data values. This is just my work where I'm finding the z-score. So this one, we're going to have 27.5. Remember, this was the one we were, this is the second one that we need to do, minus 22.7 divided by 6.5. Now, if you have an editable calculator, you know, like the one that I've shown you, then I can actually just go up, arrow up and just change the 17.9 to a 27.5, and that'll be a little faster. And that gives me the z-score for this data value. Did you get that one?
Mine came out at 0.74.
Yes, that's correct. So they just happen to be opposites. Which that means there's an easy way to do this, but we're going to go ahead and do it as if they aren't opposites, so you would know what to do if they were not. Okay, so we're going to do this a way that would work every time. So I'm going to find this in a minute. Let me get out all my colors. So we're going to find this, and I'm going to show my calculations here. I'm going to draw my picture down low so I can put my calculations here. So down here, I'm doing z's, draw my picture. Here's 0, and I'm going to have negative 0.74 over here somewhere, and positive 0.74 over here somewhere. And what we want to do is shade the area we're looking for. So this is between. Remember, that was the word they used, between. So what I'm looking for is this area in between those two z-scores. Does everybody see the area I want? Always shade the area you want. I want the area in between. Now, what I'm going to look up in the table, though, very carefully, are the areas to the left of each of these. So I'm going to look up the area to the left of the positive 0.74 and this area to the left of the negative 0.74. So I'm going to look those up. You guys all practice with me, and let's make sure we get the same answer. And I don't want you to do anything else but this right now. I want you to make sure that you got these same two numbers that I got by looking up. And notice I've indicated that those are the two areas to the left. And then Stephanie, what you were saying was that you said something about subtracting, and you were right. In the end, that is what we're going to do. Because
So we subtract those two right there.
Say that again.
We subtract those two z-scores.
Yes. Well, the two areas, not the z-scores.
Oh, okay.
So we find the z-scores, we put them on our picture, we look up the areas to the left in the table, then those areas are the things that we actually do the subtraction with. So we want this whole area, the big area, from here all the way back, that's this. And we want to subtract off this part that we don't want, which is that area to the left of the smaller one. Do you see how this flows now? This probability is the same as this probability. Here's my work for that probability. This is the calculation I need to do. And once I do that calculation, 0.7704 minus 0.2296, I get 0.5408. And Stephanie, this is your problem, so you would have to check that for us to see if it came out right.
Yes, it came out right. Thank you.
Terrific. Now, I don't know, because I quit doing mine, I don't know what the third question asks on that one. We can do the third one if you want to, but let me open it up now because we are, it's 11 after 11. And so I definitely want to give you time to ask questions that you have. Did anybody have any questions besides? Now, if you want to do the C part, I don't remember how many parts this one has, but if you want to do the C, the other parts of this, we can. If somebody has a different question you got stuck on, yeah, this was A through D. So we can keep working on this question, but if somebody has one that you would like to go over, if you didn't have any problem with this one, but you had some problems with another one, we definitely want to take a look, because after the break, we are going to be going on to 5.3. Any question? Did anybody have anything different? This was one 2 people emailed me about. That helps a lot, because then I know something I need to cover in class. Did anybody have another one that you would like me to go over? Go ahead and type it in the chat if you do, or you can turn on your mic.
I did, Professor Haynes.
Christina, okay.
It was question 10, 11, or 12. It wasn't the problem. First part, I got that. It was the B question.
Okay.
And that, the part B on questions 10, 11, or 12 is kind of where I got stuck.
Okay, well, let's split the difference. Let's go to question 11 and pull yours up, Christina, and we'll use your numbers, okay? So there were 2 more parts to this, guys, so don't forget to go back and complete the question. In fact, hopefully, if you don't do this question, if you just submit now, it may count it wrong and make you redo it. So you might not want to submit it if you're still working on question 6. So, but I'm assuming, Christina, that you've finished question 6. So let's look at your question number 11. I pulled it up on mine just so I could see what kind of question it was, but we're going to use yours. Mine says, so we're talking about the normal distribution of SAT critical reading scores. So this is number 11. And it gives a mean and a standard deviation. So Christina, tell me your mean and standard deviation.
All right. My mean was 500 and my standard deviation was 105.
Okay. And it says, assume the variable X is normally distributed. And the first one says, what percent of the scores are less than 650? Now, you said you did the first one right, so I'm going to go through this pretty quick. So it's saying, first we want to find the probability that a score is less than...
Mine was 600.
You have what?
Mine was 600.
Then let's do yours. Thank you. I forgot we were doing yours. So the probability that X is less than 600, we're going to change that to a Z-score. So we need to find the Z-score for 600. What did you get for the Z-score? You got this part right, so I want to make sure. So
yeah, my Z-score was, let's see, I got 82.89. No, it was 0.95, which converted into 0.8289.
okay, so I want the Z-score first. Let's do these things, make sure we're showing our work correctly. So first you found a Z-score by doing 600 minus 500 over 105. And what did you get for that?
0.95.
0.95. Okay, so that's the Z-score for this data value. So I'm going to put this Z-score over here. Everybody make sure, I want your work to look like this, okay? This is just scratch work over here to find the Z-score. I do want to see it, but this is what this should be written as. Then once you get that converted to a Z-score, you're ready to draw the picture. So if I drew the picture on this one, I'm just going to draw a little picture. So here's 0.95 would be over here, and they want the area to the left because it says less than. And so all we have to do is look that up in the table, which you have done. And you said you got what number? What is the area to the left of that Z-score, Christina?
0.8289.
And since that area to the left is the less than area, that's our answer. So we're going to come back up here and say, well, that probability is 0.8289. However, the question asked what percent? and they wanted it to, mine says round to 2 decimal places. So they don't want this decimal answer that we've been giving. They want us to change that to a percent, which means we need to move the decimal over 2 places. So that percent should be 82.89%. Is that what you put in, Christina?
Yes.
Okay, then that was your answer to the first part. Let's go to the B part. The B part says, how many does it say? If how many? It says if, mine says 1,000. How many does yours say?
1,000 on what?
For the B part, what does the question say?
It says, hold on. It says you would expect approximately blank SAT verbal scores would be greater than 575.
The original question, though, gave you a number of people, right?
Oh, yes. Approximately, 1,000 people.
1,000?
Yes.
1,000 people are SAT scores are randomly selected. About how many would you expect to be greater than 5? Mine says greater. About how many will be greater than? So this is a different question. What does yours say? Greater than what? Can you tell me?
575.
575. That's your question. Okay, so what I'm going to do is I'm going to go back to this A part and see how I would answer that same question if they had asked about how many out of 1,000 would be less than 600. Okay, so what I did, I found the probability that X is less than 600. The probability.
I got the greater than part
right?
worked out. It was just
Now,
I guess it's the rounding part.
okay. So let me, so this one, the first thing you're going to have to do is find this. So this has 2 parts. You're first going to have to find the probability that X is greater than 575. That's the first part. Okay. So you're going to do that similar to what we did here, except you're going to be looking for the area to the right instead of the area to the left. So let's talk about how to do that. So I'll just erase this. We'll just do that B part. So if I do the probability that X is greater than 575, then I need a Z-score for 575. (575) minus 500 divided by 105. So let's make sure all along the way if your different parts are right. 575 minus 500 divided by 105, and that should be 0.71. Is that what you got for the Z-score?
Yes.
Okay. Then drawing the picture. I'm going to draw the picture here down low. Here's 0. I'm looking for the Z-score was 0.71, so put it over here to the right. And since we're talking about greater than, that means to the right. So I'm going to shade this area. But the table doesn't give me that area. If I look up 0.71, I get the area here to the left. So I'm going to look that up. Let's make sure you got that right. So the area to the left of positive 0.71 is 7611. So far, so good, Christina?
Yes.
Okay. But I'm looking for the area to the right. Remember, this is my question here. That's the question. So how am I going to get that?
Subtract it from 1.
Right. And that's going to give me the area to the right. .2389. That's this area. Those two areas should add up to 1. Now, but the question did not say what's the probability that a randomly selected score would be greater than 575. If that had been the question, this would be the answer. But that wasn't the question. I want you to look back at the question. The question says, if 1,000 are chosen, randomly selected, chosen randomly, about how many, it means how many out of the 1,000 will be greater than 575. Well, what we just found was the probability of a single randomly selected score being greater than 575. So think of it as a percent, like 23.89%. So what we need to do to answer this question, out of 1,000, basically 23.89% will be greater than 575. Now, they don't want the percent. It says how many will be. They want an actual number. So what we're going to do is we're going to need to find that percent of 1,000. Which means, remember, of means to multiply. So basically, we're going to change that back to a decimal, 0.2389, because you never calculate with a percent. So we're going back to this. We're going to multiply it by 1,000 to see how many. We're basically just finding that percentage of 1,000. That's going to move the decimal point over 3 places, 238.9. Now, it probably wants a whole number. I don't know. I can't see on mine what it tells you to round to. Christina, can you?
Yes, it was a whole number, and it was. You've got the right answer. You filled in my blank. Yes,
okay.
Multiply by 1,000.
So, yes, if they want a whole number, they probably want 239 on this. Some questions, the rounding thing is a little weird, and we're going to talk about that as we go on in the course, because there are times when, even though this would round to 239, there are times when we're going to want to round down, but I don't think this is one of those times. I think at this point, they just want you to round it normally.
Yes, perfect. Thank you.
Okay? Right, so let me go over, because we did not do one like this in class last time. So I'm going to go over this one more time and show you what we did. And then after the break, we're going to go on to 5.3. If you have another question that you need me to answer from this section, just stay on during the break and we can work a couple more. So this one, remember the question was, they asked, out of 1,000 people, how many would have a score over 575? So what we had to first find was the probability that one score would be more than 575. That's how we start. And so that's just a regular question like we're used to. So I write it as a probability. I found the z-score for 575, rewrote the probability with the z-score. I drew a picture. Here's my z-score down here. The z-score always goes on the axis. And then I looked that z-score up on my table, which always gives me the area to the left. So I'll write the area to the left. But since this was a greater than problem, the area I wanted that I shaded over here is the area to the right. So once I knew the area to the left, the way I found that area to the right is by subtracting from 1, because the total area under the curve has to be 1, because the sum of the probabilities has to be 1. And so once I found that, now I know the probability that a single randomly selected score is greater than 575. So now if I want to know how many would I expect to be bigger than 575 out of 1,000, I need to find that percentage. So remember, so this is 0.2389 is the same thing as 23.89%. They didn't ask me what percent. They said how many out of the 1,000. So I had to figure out 23.89% of 1,000. Which means to multiply the decimal times 1,000, and that moves the decimal point over 3 places, and then we rounded. So I wanted to talk about that one more time. I'm going to leave this up here, so if any of you want to go finish number 6 so that you don't have to redo it, finish number 6, and then maybe come back and do number 11 during the break. And if you have another question from 5.2, let's give this about 10 minutes, give everybody a chance to work on finish number 6 and do number 11. About 10 or 15 minutes, if you have another question from 5.2, type it in the chat. I'll hear that, and I'll come work with you up here. If not, we're going on to 5.3 after the break. So we will meet back at noon.